Okay students, up to now you know the meaning of single linkage and complete linkage while forming the clusters. These two concepts present in the syllabus according to your GATE syllabus. Apart from single linkage and complete linkage, one more type of linkage present in the clustering, that is named as average linkage approach. Okay, syllabus point of view, single linkage is there, complete linkage is there, but average linkage is not given in the syllabus. Still we have a look on average linkage approach. Okay, then what is average linkage approach? Take that. In the average linkage approach, we are going to take the average of the distances between all the points in the cluster. For example, here distance between A comma B, this is cluster A and this is cluster B. So average means 1 by mod A and mod B. Mod A is nothing but number of elements in cluster A. Mod B means number of elements in cluster B. Okay, into summation of distance between x comma y. Now here x is belongs to A cluster, y is belongs to B cluster. This is the average linkage approach. So we are taking all the distances sum and divided by total number of pairs, right? That is the concept. When we see the single linkage approach, in the single linkage approach, we are taking the minimum distance, shortest distance among the pairs between the clusters in each cluster. Complete linkage approach, we are taking the longest distance, okay, between the 2 points in each cluster. Okay, in average linkage, we are taking the average value, that means summing all the distances between possible pairs of the data divided by total number of elements in the cluster A and total number of elements in the cluster B. This is the meaning, right? So now listen here. I want to apply this mechanism. In the some example distance matrix, right? To analyze the total clustering procedure, like previously I taken one sample matrix, implemented single link and complete link approach. Similar manner, let us take one sample example to identify the clustering method by using average linkage. Okay, so average linkage means we are taking the average distance, that means summing all the distances divided by total number of pairs in the cluster, right? Okay, now take the example question. Consider the question is consider the following distance matrix and form the clusters using agglomerative clustering with average linkage approach. With average linkage approach. Okay, take the points. Data points are so diagonal values are always 0. Yes, this is the distance matrix given. Now we need to find out the clusterings or number of clusters and what are the elements formed in the cluster by using the average linkage approach in a agglomerative clustering, right? So procedure is the same. First we need to take the small value. In this total, what you have, small value is 3, correct? Now first select 3. Small unit, that is 3. Okay, cluster is, this 3 is the connection between the D and E, so that D and E elements are similar to each other. So this is the cluster. You know, shortest distance means more similarity. All right. Now reform the matrix. Reform the matrix using average linkage, not the single link, not the complete link, average linkage. Okay, that is A, B, C, D, E and F. So A, B, C, D, E and F. Okay, all right. So diagonal values are 0. Put them 0, 0. All right. Now AB value not changed. AC value not changed. Here we need to find out AF value not changed, and BC value not changed, and BDE we need to find out, and BF value not changed, 16. CDE we need to find out, and CF value not changed, 8, and DEF we need to find out. Okay, so what is the value here? Average linkage. So how to find the average distance? Now see this. First of all, what you need to take? Distance between A and DE. A comma DE. Okay, so here what is the value now? Average of distance between AD and distance between AE, average divided by how many pairs are formed? 2 pairs. That is the average. Average means this. So now average value is equal to distance of AD. Distance of AD is 12 plus distance of AE. AE is 18 divided by 2. Then calculate this. 18 18 plus 12, 30 divided by 2, that become 15. So now this question mark is changed to 15. Similarly, distance between B and DE. B, D, E. Now tell, average is equal to, okay, distance of BD and distance of BE divided by 2. That means this is the summing, right? Distance of first pair plus distance of second pair divided by 2. So average is equal to distance of BD. BD distance is 20. BE distance is 14 divided by 2. So 20 plus 14, 34 divided by 2, that is 17. Now here this is changed to 17. Next क्या है? Distance between CDE, C comma DE. Now we are taking the average. Average means distance of CD plus distance of CE divided by 2, number of pairs. Right? CD, C and D, 13. C and E, 7. 13 plus 7 divided by 2. 20 divided by 2, that is 10. So this is changed to 10. Alright. Now, distance between, what is that? F and DE. F and DE. Then what we need to take? Average is equal to distance of FD plus distance of FE divided by 2. Divided by 2. Okay. So this is equal to distance of FD. FD 10. FE 12. 10 plus 12 divided by 2. That is 22 by 2. That is equal to 11. So this is changed to 11. Okay students, I hope you understand what is the average linkage now. Average linkage means sum of the distances divided by total number of the pairs. Okay, sum of the distance divided by total number of the pairs. That is the average linkage. Complete linkage means what? Maximum distances of distance of the given pairs. Right? Single linkage means what? Minimum distance of the given pairs. Average means what? Sum of distances of all the pairs divided by total number of pairs. Right? Okay. So now, what is the next step? Select the smallest value. What is the smallest element in this? 5, 16, 9, 15, 17, 10, 10, 16, 8, 11. Smallest is 5. Therefore, select small unit, that is 5. New cluster is this 5 is AB pair. So A and B. These two elements are similar. That's what they are grouping into one cluster. Distance is small means what we are saying, similarity is high. Okay, AB is the new cluster. Now reform the matrix like this. AB, right? C, DE, F. AB, C, DE, F. So as of now, two clusters formed, diagonal value will be 0 like this. Okay, so now CAB question mark, CAD, ABDE question mark, ABF question mark. Next, CDE question mark, CF question mark, and DEF question mark. Okay, or else if you want to take the previous values you can directly take. Because of DEF, there is no change. Directly you can put 11 here. And C and DE, there is no change. Directly you can put 17 there. Okay. So here directly you can put 11 because previous value is not changed. No? C and DE, already you calculated previously, that is not changed. See this. C and DE, this is not changed. And F and DE not changed. These two clusters are not changed. So this information will be as it is. Okay. This information will be as it is, you can maintain. Correct. Then C and F. C and F value is not changed. Na? C and F value is also not changed. That is equal to 8. This you can maintain as it is. Okay. So now what we need to find out? We need to find out these values only. First tell me average. Distance of C comma AB. Then average equal to distance of CA plus distance of CB divided by 2. Okay, that is CA distance, CA, AC 16 and CB, okay, BC 9, CA, CB 16 plus 9 divided by 2. This is 16 plus 9 divided by 2. Calculate that. 16 plus 9 divided by 2, that is 12.5. Okay. So now this is replaced with 12.5. Next, distance between DE comma AB. Okay, then what is the average? Average is equal to distance of DA plus distance of DB plus distance of EA plus distance of EB divided by 4 pairs. Calculate this. Okay, DA, DB 12 plus 20 plus EAEB 18 plus 14 divided by 4. Calculate that. 12 plus 20 plus 18 plus 14, 64 divided by 4, that is equal to 16. So this average is 16. Okay. So now this is replaced by 16. Okay. And next one is what? Distance between F comma AB. Okay. So F comma AB, average is equal to distance of FA plus distance of FB divided by 2. So FA, FB distance देखो. FA distance is 10, FB distance is 16, 10 plus 16. 10 plus 16 divided by 2. This is 26 divided by 2. This is what? 18 divided by 2. That is, 13. 26 divided by 2. 13. Right? So now this is replaced with 13. So here these values are not changed because these all are same to same. CDE already calculated, FDE already calculated. Then what we need to do? We need to take the small value. What is the small value here? Small value 12.5, 16, 10, 13, 8, 11. So 8 is the small value. Correct? Okay. Now select small unit. That is 8. Okay. New cluster is what is the new cluster? Tell me. This 8 is the link between C and F. C, F. Now new cluster is formed, C and F. Then automatically our matrix will be reformed, AB, CF, DE. AB, CF, DE formed. So diagonal values are same. Diagonal values are zeros. So 0, 0, 0. Right now? ABCF. This we need to calculate. ABDE as it is now. So here ABDE value already present, that is 16. Here no change. Correct? Then CFDE here value will be changed. Okay? So what are the values changed? Only those values we need to calculate. Now see this. Distance between CF, AB, right? Average is equal to distance of CA plus distance of CB plus distance of FA plus distance of FB divided by total pairs are 4. Number of pairs are 4. This is CA, CB distance देखो CACB 16 plus 9 16 plus 9 plus FAFB FA 10 FB 16 10 plus 16 divided by 4. Calculate this. 16 plus 9 plus 10 plus 16 divided by 4, that is 12.75. Okay, so now this is replaced by 12.75. Clear now? All right, next D value. Distance between DE, CF. Right, now calculate the average. Average is equal to summing of all the distances. Distance between DC plus distance between DF plus distance between EC plus distance between EF divided by total number of pairs are 4. Okay, now see this. DC, DF. DC 13. DF, FD 10. 13 plus 10. 13 plus 10 plus EF. Now see this. EC 7. EF 12. 7 plus 12. This is 7 plus 12 divided by 4. Calculate this. 13 plus 10 plus 7 plus 12. This is equal to 42 divided by 4. That is 10.5. Okay. So now this is replaced by 10.5. Bus. So now what we need to do? We need to select the smallest value. Smallest value is what? 10.5. Select small unit. Why small unit we are selecting? When the distance is less, similarity is more. Therefore, we are clustering data based on similarity. Okay, that is equal to 10.5. So new cluster is, what is the new cluster here? CFDE. 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 Is it clear now? Therefore, after this, we are reconstructing this. What you have? AB, then CFDE. Right, AB, then CFDE. diagonal values are zeros. Then what is this? Right? What is the distance? So obviously that become a small, that will be grouping. Anyway, calculate that average of, okay, distance between CA plus distance between CB plus distance between FA plus distance between FB plus distance between DA plus distance between DB plus, okay, distance between EA plus distance between EB divided by total number of 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 pairs possible, right? All right. Now calculate that. CA, CB. CA, CB, 16 plus 9. So this value is 16 plus 9 plus FA, FB. FA 10, FB 16. Okay, 10 plus 16 plus then DA, DB. DA, DB. Take now. DA 12, DB 20. 12 plus 20 plus EA, EB. EA 18, EB 14. 18 plus 14 divided by 8. Calculate the average. That is 16 plus 9 plus 10 plus 16 plus 12 plus 20 plus 18 plus 14 divided by 8. This is equal to 14.375. So now this is changed to 14.375. That's it. So now what is this meaning? Select the small value, small unit, that is 14.375. Okay, new cluster is A, B, C, D, E, F. Bas. These all are the clusters, or else A, B, C, F, D, E, like this. This is the new cluster. Then after that, distance matrix become 0. When distance matrix is 0, stop the process. So if you want to draw the dendrogram, the highest value is 15 only. So here you just see this. In the dendrogram, if you see the points, all of you watch this. First of all, dendrogram unit is 3. I am writing like this. This is the dendrogram. A, B, C, D, E, F total. So this is 0. Okay, this is 3. 3 and after that 5. After that, in the 3 cluster is formed, in the 5 cluster is formed. Okay, after that in the 8 cluster is formed, here 8. Okay, next in the 10.5 cluster is formed. Okay, this is 10.5, let us take, cluster is formed, and after that 14.375, here also cluster is formed. 10.5, 14.375, 14.375, here also cluster is formed. Okay, then what are the clusters formed? You just see this. First of all, in the unit 3, cluster is formed D and E. So this is the cluster. After that, unit 5, AB. This is formed AB. Okay. After that, unit 8, CF. These two are formed. Color, let me change the color. This is formed. Then C and F. This is formed here. Right? And next, after C and F, CFDE, that is 10.5. CFDE. CFDE, CF and DE. This is another cluster. All right. Then after that, last one is AB and remaining this. So clusters are formed like this. First cluster is formed at unit 3. Okay, unit 3, first cluster formed. Unit 5, second cluster formed. Unit 8, third cluster formed. Unit 10.5, okay, fourth cluster formed. Then the last one, 14.375, like this. So number of clusters, if you want to see, it is like this. This is the K1, this is the K2, right? This is the K3, this is the K4, this is the K5. So total number of elements are 6, number of clusters possibility is 5. All right. Okay. So what are the elements present in the first cluster? In the first cluster, देखो, K1 is equal to DE. Next, K2, AB. K3, CF. K4, what is that? CF, DE. This is one cluster. Then K5 means what? AB, CF, DE. This is the cluster. So these two are all are formed here. So like this, data will be formed into a clusters by using the average linkage. Okay. So I already explained the clustering with the single linkage, clustering with complete linkage, and clustering with the average linkage. Okay, like this, clusters are formed in the unsupervised learning, that is agglomerative clustering mechanism. Okay, students, hope you understand, right? Now I am showing you the slides, copy the information. This is our question. From this, our question started. Consider the following distance matrix. Yes, this one. So every time I calculated the average distance. Average. Copy it quick. Okay. Next. Okay. 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 All right. Now finally, this is the answer. This is the dendrogram. Okay. Copy it quick. Copied? Yes. All right. Okay, dear students. So as of now, agglomerative clustering technique is completed by using the single linkage, complete linkage and average linkage. Okay, students. So I hope you understand the same procedure, right? So what you need to do is take one small example. I already gave the previously practice set question. In that practice question, apply three methods. Three methods you can apply. What are the three methods? Single linkage, complete linkage, average linkage. Three methods you can apply on the sample data practice question which I given earlier. Also, if you want to take your own matrix, then you can take. Correct? Apply the three kinds of the linkage methods. Identify the clusters formation. Okay. Hope you understand this concept. Up to this, agglomerative clustering mechanism is completed. Agglomerative clustering, bottom to top approach of a clustering is over. Okay, students. Now we are going to start divisive clustering, that is top to bottom clustering, right? Now see this heading. Divisive clustering. This divisive clustering is the top to bottom clustering. Okay, students. So before this, we already discussed the agglomerative clustering, that is the bottom to top approach of a clustering method. Now this is the divisive clustering, that means top to bottom approach of a clustering. As we know that clustering is the unsupervised learning method or unsupervised learning algorithm. So in this clustering, based on the similarity, we are going to group the data points. Okay, so that within the cluster, similarity will be very high. Between the clusters, dissimilarity will be very high. That means data points within the cluster, similarity will be more. Data points between the cluster, dissimilarity will be more. Okay, so when we are talking about the bottom to top approach, data points are joining into a clusters. So when we are joining the data points into a clusters, we are focused on the similarity, shortest distance. Okay, simple linkage or single linkage, correct, or else complete linkage. We are just to concentrate on the similarity within the cluster. But now it is a top to bottom approach. So when we are taking top to bottom approach, we are splitting the total data set. Big cluster, major cluster will be splitting into subclusters. So when we are splitting the major cluster into subclusters, we need to concentrate on the dissimilarity. That means one cluster will be splitting into another cluster. So dissimilarity basis may we are going to splitting the cluster into subclusters. So here in the divisive clustering, we have a certain number of the steps. Okay, first let me explain the points. Later I am going to write the steps on screen. Okay, first thing is what? Based on the given input data set, we are going to generate the distance matrix by using the Euclidean's distance. Euclidean's distance formula used between the data points to generate the distance matrix. Okay. After that, by using the either Kruskal's algorithm or Prim's algorithm, we are going to generate the minimum spanning tree. That means we are arranging the total pairs of the data, according to the distance matrix into a ascending order. After that, construct the total minimum spanning tree. In that construction, joining the edges between the data points starting with a minimum cost, and continue this kind of joining until all the data elements are participated. Okay, without forming the circuit or loops, we are going to connect all the edges between the data points. So in the minimum spanning tree, there is no loops are present. It is a undirected graph, so loops are not present. You know, we are connecting the edges between the data points by covering all the data points, okay, without forming the loops or without forming the circuits. After constructing the total minimum spanning tree, we are going to apply the complete linkage methodology to divide the data points into a clusters from top to bottom. You know that in the complete linkage process or in the complete linkage approach, we are concentrating on the maximum distance. That means dissimilarity between the clusters must be high. So maximum distance is our major parameter to divide the cluster into subclusters. To split the cluster into further subclusters, we need to concentrate on the maximum distance or maximum cost. That means resolve the maximum cost edge between the data points. That means dissolve means delete the edge between the data points which is having the more weightage. That means more cost edge will be deleted, dissolved, so that we are getting the clusters. When we dissolve the edge between the data points which is having the more cost, that means more dissimilarity, automatically we have the two different clusters. right? So continue the same procedure, that means dissolve matlab delete the edge between the data points which are having the more cost or more distance. So continue this process until all the individual data points are represented in the system. So delete all the edges based on the weight. Because of it is complete linkage, always we are removing or deleting or dissolving the edge which is having the more cost. More cost means more distance. More distance means more dissimilarity. More dissimilarity means exactly clusters are splitting. Got the point? After that, use the dendrogram and represent the respective clustering sequence. So this is the procedure to apply the divisive clustering, top to bottom clustering. Okay, so these points I am going to write on screen as a stepwise. Correct, na? Okay, take that. Step 1. Generate the distance matrix based on the given input data set by using the Euclidean distance formula. Euclidean distance formula. That is what? Distance equal to square root of x1 minus x2 whole square plus y1 minus y2 whole square and so on. So how many input parameters are given? Based on that we are taking the distance like this. If only one column is given, that will be denoted as x. If two columns are given, that will be denoted as x and y. If three columns are given, that will be denoted as x, y, z and so on. Okay. So how many columns are given? Uska accordingly we are going to find out the distance between the pairs or distance between the points. Okay. All right. So step 1 is generate the distance matrix based on the given input data set by using the Euclidean distance formula. Okay. All right. Second step. Create the minimum spanning tree okay based on the distance in bracket cost between the data points by using Kruskals or Prim's algorithm. Okay, that means arrange the total edges based on the cost. That means based on the distance, arrange the total number of edges. Correct? So after that, here itself create the total or else construct the total minimum spanning tree by connecting the edges between the data points starting with minimum cost. Till cover all the data points. Okay, without creating the loops or circuits. In the tree. Okay students, just listen. First step is generate the distance matrix based on the given input data set by using the Euclidean distance formula. So we have a distance matrix. After that, by using the Kruskal's algorithm or Prim's algorithm, we are going to arrange the data in a ascending order. That means pairs of the data elements with respect to the distance matrix, we are arranging them into a ascending order. After arranging the pairs of a distance matrix into a ascending order, we are going to construct the total minimum spanning tree by connecting the edges between data points, starting with the minimum cost or minimum distance, and continue this process until all the data points are participated without creating the loops or circuits in the tree. Okay, this is the step 2. Now, step 3. In step 3, use the complete linkage approach to form the clusters. Use the complete linkage approach to form the clusters. That is delete or remove or dissolve edge which is having more cost. More cost is nothing but more distance. Delete or remove or dissolve the edge which is having more cost. More cost means more distance. So more distance is nothing but more dissimilarities. More dissimilarity between the clusters. More dissimilarity between the clusters. Okay, right. Continue the same process. Okay. Step 4. Repeat step 3. Repeat step 3 until all the individual data points are present in the cluster. Repeat step 3 until all the individual data points are present in the cluster. That means until all the edges are dissolved, we are going to continue the step 3. That means until all the edges are removed in the graph or in the tree. Until all the edges are removed in the tree or graph. Because minimum spanning tree is a undirected graph. There is no directions. Undirected graph. Okay. So this is the meaning of divisive clustering. So in the divisive clustering, we are going to form the clusters from top to bottom. When we are taking top to bottom approach, first we have a major cluster that will be splitting into subclusters. When we are splitting the major cluster into subclusters, we are going to concentrate on the more dissimilarity. More dissimilarity means more cost or more distance. So that is the reason after creating the total minimum spanning tree, remove the edge which is having the more cost. Okay, so when you remove the edge, that become a 2 clusters. Okay, continue that process until all the edges are removed in the minimum spanning tree or in the undirected graph. Then automatically at the end you have a full-fledged cluster information. Okay, so that major cluster will be splitting into the individual data points clusters. So that is called as the top to bottom approach of a clustering method. Okay, that top to bottom clustering is named as the divisive clustering. So these are the steps required in the divisive clustering. Okay, first copy the steps, later we will see the implementation of these steps by taking some example data set. Okay students, all right. Copy the steps. Copied? Okay, now take this one. Step 3, step 4. Okay, so now take the input data set. So this may be the example or also the question. Okay, consider the following distance matrix and report the clusters by using divisive clustering approach. Consider the following distance matrix and report the clusters by using divisive clustering approach. So in this statement, they already giving the distance matrix. When distance matrix is already present, our job is already simplified. If distance matrix is not given, if they given the input data set, from the given input data set, we need to formulate the distance matrix. After formulating the distance matrix, we are going to apply the minimum spanning tree logic. That means arrange the pairs of the data points in a ascending order based on their cost. Later construct the total minimum spanning tree. Then apply the complete linkage for the dissimilarity, more dissimilarity. Okay students, alright. So now this is the input data set given, input distance matrix P1, P2, P3, P4, P5, P6, 6 data points given. Okay, P1 to P6, right? So 0, 0.23, yes, this is the distance matrix given. You know the meaning of this distance matrix. Okay, distance between two data points given. Distance between two data points given. You know, P1 to P1 distance is 0. P1 to P2 distance is 0.23 units. Okay, P1 to P3 distance is 0.22 units. P1 to P4 distance is 0.37 units and so on. Correct now? So like this, they given the distance matrix. Correct? Alright. Now we are going to see the solution procedure for this question. So in the solution, what we are going to do? First we are going to arrange the data in ascending order. Arrange the data pairs into an ascending order based on the distance. Based on the distance. So this pair is called as the edge. So data points pair. Data pair is called as the edge. Next, distance is called as the cost. Okay, so now arrange this into the ascending order. First see this is in this given data. What is the smallest data? Ascending order, low to high. Smallest data 0.11. 0.11 data pair is P3, P6. P3, P6. That weight is 0.11. Next, this is over. Now, next smallest data point is what? 0.11. After that, 0.14, that is P2 and P5. P2, P5. This pair weight is 0.14. Over. Then what is the next smallest data? Okay, distance 0.15. Okay, two elements are there. What are two? P4 and P3 to P4. P3 comma P4. That is 0.15. Next one, P2 comma P3. P2 comma P3, that is 0.15. Done. And after that, next smallest, what is the next smallest in this? Next smallest is 0.2, this one. So P2 to P4, P2 comma P4, that is 0.2. And next one is what? 0.22, 0.22, 2 points are there, P1 to P3 and P4 to P6, P1 to P3 and P4 to P6. So these are the data points with cost 0.2 to 0.22. Okay. And next one. Okay, 0.22 over. And after that 0.23, yes, this one, 0.23, 0.23. So what is this? P1 to P2, P1 to P6, P1 to P2, P1 to P6. Okay, that is 0.23, 0.23, wait, over. And after that, next highest, next small is what? 0.25, that is P2, P6, P2 comma P6, that is having 0.25 cost. Next, 0.25 is over. Next one is what? 0.28, yes, this one, P3, P5, P3, P5, that is 0.28. Next 0.29, that is P4, P5, P4, P5, this is the 0.29. Alright. Next one, 0.34, 0.34 is P1, P5, 0.34. Next, 0.37, P1, P4, P1, P4, 0.37. Last, this is what? P5 and P6. Point P5, P6. That is what? 0.39. Okay. So based on the distance, name as the cost, we arranged the data pair into an ascending order. Ascending order mein the total data points are arranged. After arrange the data points in ascending order, we need to construct the minimum spanning tree by connecting the or providing the edges between the data points starting with minimum cost. Okay, right. So spanning tree is like this. Spanning tree is like this: P3, P6, P3, P6. These two data points are connected with the edge. That edge cost is 0.11. Next, over. Then P2, P5. Next is smallest cost, P2, P5. So here P2, then I take in P5. These 2 points are connected with the edge. Edge cost is 0.14. Over. Then P3, P4. P3, P4. These 2 are connected with a edge cost of 0.15. Okay, correct. P3, P4. P2, P3. Yes, these 2 are connected with a cost of 0.15. Ready? Then P2, P4. If I connect P2, P4, it creates the loop. That's what we are not connected. So this we are not using because this creates the loop. Loop created. So in the minimum spanning tree, loop is never created. When loop is created, then that is not called as the spanning tree. Correct, no? So that is the open graph. Next, P1, P3. P1, P3, right? P1, P3, there is no circuit. What is the weight? 0.22. Clear now? And after that, this is over. Then P4, P6. If I put P4 and P6, there is a loop. So here loop created. Loop possible. That's what, don't use it. P1, P2. P1, P2, if I connect, again loop is there. Loop formed. Don't connect. P1, P6. P1, P6. Again there is a loop formed. Don't connect. P2, P6. Again loop formed. So don't connect. P3, P5. P3, P5. Yes, again loop formed. Don't connect. Then P4, P5. P4, yes. P5. If I connect this now, again loop formed. Don't connect. Okay. Characteristics of MST, minimum spanning tree, is there is no circuits or loops in the tree. Next, P1, P5. P1 and P5. Yes, loop created. Don't connect. Then P1, P4. P1, P4. Loop connected. Loop created. Don't connect. P5, P6. Yes, there is a loop. So don't connect. So when loop is created, don't connect those data points with the edges. Okay, leave them. So this is the complete spanning tree of the given distance matrix. Given distance matrix, complete spanning tree is this. Now we are going to apply the complete linkage process to form the clusters. So here what we need to do? Complete linkage. Linkage to split the clusters from top to bottom with more dissimilarity. With more dissimilarity. Then what is this meaning? What is this meaning? Remove the edge between the data points. Remove the edge between the data points which is having more cost. Which is having more cost. Okay. All right. So whatever the edge is having more cost, that will be removed, deleted. That removing itself called as the cluster formation. Okay. Now see this. According to our spanning tree, more weightage edge is what? This one. Now here remove edge between P3 and P1. P3 and P1. So here two clusters are formed. That is independent cluster P1 and other clusters are there, na? Dependent clusters. What are the dependent clusters? That is a P3, P6, P2, P5 and P4. Like this cluster is formed. Okay. So two clusters are formed. That means major cluster splitting into two subclusters. In that P1 is a independent and remaining again further splitting is possible. Dependent cluster means here splitting is further splitting. Further split is possible. Is it clear now? All right. So what is this meaning? Now our graph is looking like this. If I remove that P1, so P3, P4, P2, P5 and P6, this is formed. This is present. This is 0.11, 0.15, 0.15 and 0.14. Now again take the edge which is having the more cost. What is the more cost here? More cost edge is 0.15, 0.15. If you see these two edges, this is the P4 is independent edge, independent node, and but P2 is the dependent information. It is having dependent. That's what resolve. That's what remove edge between P3 and P4. Now P4 become independent cluster. Now P4 become independent cluster. Is it okay? All right. So now we removed this. This edge is removed. First this edge is removed. And continue the same procedure. Now the graph is looking like this. Graph is P3, P2, P5 and P6 like this. Okay, 0.11, 0.15 and 0.14. Now what we need to do? Take the edge which is having more cost, remove it. Then remove edge between P3 and P2. P3 and P2. Okay. So now here two clusters are formed. Okay. That is P3, P6 cluster and P2, P5 cluster. These are not independent cluster. Here split is possible. And here also split is possible. So these are not independent clusters. Okay. All right. So our graph is looking like this after this. P3, P6. Okay. Then P2, P5. Okay. With the cost is 0.11, 0.14. Now take the more cost 0.14. Remove the edge. So now remove edge between P2 and P5. Okay. Now P2 and P5, two independent clusters are there. Independent clusters. So no need of the further splitting here. Okay. All right. Then what is the next status of our graph? P3, P6. P3, P6. So this edge cost is 0.11. So only one edge is there. Remove this. Okay. So remove edge between P3 and P6. Remove the edge between P3 and P6. Now P3, P6. Two independent clusters present. When we have all the independent clusters, then we can stop the process. Correct, no? So in the total minimum spanning tree, all edges are removed. When all edges are removed means what? we have a full-fledged independent clusters with independent data points clusters. So the major cluster will be splitting into further clusters. Okay, this procedure we are continuing with the step where we have a independent clusters in the hierarchy diagram. This is the top to bottom decomposition or top to bottom clustering, that is the divisive clustering. Okay, all right. So now we are forming the clusters. Okay, suppose if you put the dendrogram, it is like this. Dendrogram, this is 0. So from where we are getting the cluster splitting, the first one is 0.22. This is 0.22. Next one is 0.15. Okay, and next one is 0.14. Okay, next one is 0.11, like this. Okay, right. So now batao the total cluster, that is P1, P2, P3, P4. We can say P1, P2, P3, P4, P5, P6. This is the cluster set, main cluster. Okay, so this will be dividing into two parts here. Two parts. Okay, so this is directly the P1. What we can say? Yeah, independent cluster P1. P1 is this. And after that, this is the another one. Okay, then once we are coming here, 0.15, again we are dividing this into two parts. One is the independent. What is that independent one? P4 na? P4. And we have this. Right? At the same time, again we are dividing this into two parts. This is divided into two parts, right? What are the two parts? P3, P6, P2, P5. So here, then when it is coming like this, here we have a 2 points, 2 branches, P2, P5, P3, P6. So this is P3, P5, P2, P5 and P3, P6. And next one, when we enter into the 0.14, right, then P2, P5 both are splitted. So this will be splitting into two parts. This is the P5, this is the P2. Right? So now this is still present. Then that is coming into the next level here up to this here. This will be dividing into two parts now. So those two parts are P6 and P3, like this. These are the clusters. This is the top to bottom approach. Top to bottom approach means we are taking the major cluster and further clusters are splitting like this. Okay, so major is this. This is the input set. Input set is formed like this. This is input set. This is the first K1 cluster design. Next again this level. Again this level. Again this level. Okay, that means first major is K1 na? Sorry. starts with the major one. This is the K1. Next, this is K2. Then this is K3. Okay. Then this is K4. This is K5. So total, how many elements are there? 1, 2, 3, 4, 5, 6. 6 elements are there means total 5 clusters are formed like this. Is it okay? So here major cluster is what? Top to bottom approach. See, cluster 1, P1, P2, P3, P4, P5, P6. This is one cluster. Then K2, what is this meaning? So here P1, right? P2, P3, P4, P5, P6, like this. Splitting top to bottom. Now K3, right? P1 is already present. Then here what is there? What is happened here? P2, P3, P5, P6. This is 1. And again P4 is 1. Like this. Okay. Now K4. P1 is already present. Okay. P4 is already present. Now this is what? P2, P5 become one cluster and P3, P6 become another cluster. Like this. All right. Is it clear? Now P cluster 5. What is this? P1 is there. Next P4 is already there. Now P2 separated, P5 separated. Then P3, P6 present. Fine. Now this is 1 and major is this. Okay, still we want the individual cluster, this one. Then K6 is what? K6 is P3 separate, P6 separate. Then they are in this. Okay, then P2 separate, P5 separate. They are in one cluster. Correct? So now here one is missing. One second. Let me draw this once again. Cluster drawing. This is 2. Yeah, this is right. Now P2, P5, P3, P6. Now these are present in one cluster. Then after that P4. Again these all are present in one cluster. Correct? So after that what you have? P1. This is also present in one cluster. Like this. This is the final diagram. So in the final what you have? P1, P2 all independent. So see this, nodes are independent. P1 is separately present, P2 separately present, P3 separately present, P4 separately present, P5 separately present, P6 separately present. Okay. So this is the first top single cluster. This single cluster we are going to splitting into two subclusters. Again, independent cluster is P1, dependent cluster, ye dekho, here two clusters we divided, two. This is independent, leave it. And after that, this one is there now, that is again divided into two parts. So this is independent, leave it. Independent elements are leaving. Then this portion is there now, that will be dividing into two parts. Okay. So now, after that, this become independent, leave it. Independent, leave it. Now this will be divided into two parts, like this. Then this is left. Now, once you are coming into the last one, that is present, P1 present, P4 present, P2 present, P5 present. Now P3 will be independently divided. So all are independently present. If you want to see independent is separate, no need to put the cluster, that I can able to represent like this. Independent nodes, if you want, write like this: K1, P1, P2, P3, P4, P5. This is one cluster. P5, P6, no? P6 also present. P6. This total is one cluster. Now K2. P1 is independent. So P2, P3, P4, P5, P6. This is dependent. Now K3. P1 is independent. Leave it. Now this will be dividing into P4, P2, P3, P5, P6, like this we are taking. Now K4. So P1 is there, P4 is there. Now this become P2 and P5 and P3 and P6. Dekho, like this. Next K5. P1 is independent, P4 is independent. Now P2 become independent, P5 become independent. Now P3 and P6 still they are in the cluster. Okay, right. Now come to K6. P5, P1, P4, P2, P5. Okay, now P3 become independent, P6 also become independent. Okay, this gives the more clear picture now. So in totally bottom contain all independent data points. When we are moving bottom to top, first this is one cluster. Bottom to top, if you are taking, this is one cluster. And next this P3, P6 one cluster, P2, P5 one cluster, and P2, P3, P5, P6 is another cluster. Correct. Then after that, P2, P3, P4, P5, P6 is another cluster. At the end, these all are present in the last cluster. So bottom to top, if you are seeing, independent data points are joining into clusters. Top to bottom, if you are seeing, major cluster will be splitting. That's it. Bottom to top follows merging. Top to bottom follows splitting. Like this. This is the procedure. So this is the clear picture. Now, major cluster splitting into independent clusters, independent data points. Okay, that is the top to bottom. This we are saying top to bottom approach. This is the top to bottom approach. Take the major data set and continue the further splitting. Top to bottom. Okay, students, hope you understand this procedure, right? Okay, copy it. Actually here again I am carry forwarding the clusters. इसको भी हम split कर सकते. If you want, remove this. This you don't want, and this is not required. This is not required now because independent one. Then this is not required. This is not required. Now this is not required. Independent one. Now this is not required. Not required. This is not required, and now this is not required. Independent one. Now this is not required. Not required. Not required. not required. This is also not required. So now all the points are become independent points. Is it okay? Right. This one and this one same to same. Same to same. That means top to bottom decomposition. Okay. Major cluster will be splitting into sub clusters until getting the independent data point cluster. Okay. Right. Now I am showing you the screen. Copy that. This is the screen, all of you, please copy it. Okay. Copy it quickly. Copied. Copy it fast. Okay. Completed copy. Yeah. If you take the all data points combination is major cluster K1. From that we are splitting into further. So total 6 elements are there, 6 clusters from the independent element cluster to union of all the independent elements. Okay. All right. So copying done. Hope you understand the procedure of the division clustering. Okay. So in the division clustering, what are the steps present? First step is what? By using the Euclidean distance, we are preparing the distance matrix with respect to the given data set. Later, arrange the distance matrix data points pairing into a ascending order based on the distance. So data point pair is called as the edge and the distance is called as the cost. So when we are arranging the data points distance in the ascending order, we can construct the minimum spanning tree. In the minimum spanning tree, join the data points with edges starting with the minimum cost, and cover all the data points without form the self loop or without form any circuits in the tree. After that, use the complete linkage method. Complete linkage. Remove the edges between the data points to form the cluster. In that complete linkage, we are taking the maximum cost. Maximum cost means maximum distance. Maximum distance means maximum dissimilarity between the clusters. Okay, that's what complete linkage process is. Approach is used to remove the edges which is having the more cost. Okay, we will continue this process until all the edges are removed in the spanning tree. Okay, or else until all the independent data point clusters are formed in the hierarchy. This is the procedure required for the divisive clustering. I hope you understand the procedure. Okay, students. So we will see another question related to this divisive algorithm. So I given the first question. So we will solve the another question also. Later I will give you the practice question. Okay. In that practice question, you may understand the concept of divisive algorithm with your own practice. Okay. So there are two types of clusterings are there, bottom to top and top to bottom. Bottom to top is the agglomerative clustering, top to bottom is the divisive clustering. Okay, these two methods I already explained. I hope you understand the concepts. Alright. Okay students, now we are going to see another question related to the divisive clustering, that is top to bottom clustering. Okay, take the question. Consider the following distance matrix. In bracket, dissimilar matrix. And report the clusters. By using divisive clustering technique. Consider the following distance matrix, also named as dissimilar matrix, and report the clusters by using divisive clustering technique. Okay, take this. Yes, this is the question, students. Please identify the question. In the question, distance matrix given. Distance matrix is also called as the dissimilar matrix. One cluster to another cluster, how much dissimilarity present, how much distance present, that will be the information given here. So 0.8 to 0.8 dissimilarity 0, that means A point both are similar. Okay, point A to point B similarity, dissimilarity is 2, that means distance is 2, means more distance more dissimilarity, less distance more similarity. Okay students, so this is the distance matrix which indicates the dissimilar matrix. Now we are going to form the clusters. So clustering is the method of unsupervised learning, as you know that. In the unsupervised learning, we are going to take the input data and form the groups based on the similarity. Okay, Similarity formation requires the distance. According to the distance, we are treating the information as a similar or dissimilar. When the distance between data points are very less, then we can say data points are similar to each other. When the distance between the data points are very high, then you can say data points are dissimilar to each other. Okay students, distance is small, distance is less, that indicates more similarity. Distance is more, that indicates more dissimilarity. Okay, all right. So this is the dissimilar matrix or distance matrix given. Now we need to form the clusters by using the divisive clustering technique. Already you know the procedure of the divisive clustering technique, which I already explained in the previous example. Okay, theory portion explained and also example is covered. So apply those steps in this question, form the clusters. Okay, what are the steps? First, to generate the dissimilar matrix or distance matrix based on the given input data by using the Euclidean distance. Okay, so already in this question distance matrix given, so no need to use that step. Okay, we are using that step, that means Euclidean distance, to generate the dissimilar matrix when the data points are given. Here already dissimilar matrix is given, so no need to use the Euclidean distance. Clear? All right. Now we are going to prepare the MST, minimum spanning tree. Okay. Before generating the minimum spanning tree, we are going to arrange the data points in a ascending order based on the distance. Okay, arrange the data points. Data points means pair of the points. Pair of the point is nothing but a edge. Distance is acting like a cost. So arrange the given pair of the data points into a ascending order to construct the MST, minimum spanning tree. Okay, what are the characteristics of minimum spanning tree? Minimum spanning tree characteristics are, there is no loops formed in the tree. No loops formed in the tree. If loops are formed in the tree, that is not a spanning tree. And the second one is what? Every point in the tree is visited at least once. Visited at least once. That means at least once all the data points are visited in the tree. One edge must be connected to every data point. Okay, so MST, minimum spanning tree, is a complete tree, complete connected tree. Okay, then in the minimum spanning tree, if we have a n nodes, n minus 1 edges are present. So these are the characteristics of minimum spanning tree, right? So now we are going to construct the minimum spanning tree based on the given dissimilar matrix. Okay, all of you follow that and do it fast. Okay, follow the procedure. Here I am writing the MST, minimum spanning tree characteristics. MST means minimum spanning tree. Characteristics are, first one, no closed loops occurred. Second, each point is visited by at least one line in bracket edge. Next, the tree is connected. Connected tree. See, all the nodes are compulsory having the connections. Next point. If tree contain n nodes, then n minus 1 edges are present in the tree. Okay, so these are the characteristics of a minimum spanning tree. Okay, so by using the Kruskal's algorithm or Prime's algorithm, we are going to construct the minimum spanning tree. Before construct the minimum spanning tree, we need to arrange the dissimilar matrix into a ascending order. After arrange the data into a ascending order, we start the construction of a minimum spanning tree by joining the data points with an edge by concentrating on the low cost, low cost ascending order. Okay, so minimum spanning tree. So okay, low cost edge will be joined first and continue the same procedure until completion of all the data points connected at least with one edge. Okay, there is no self loops formed in the tree. If self loops are formed in the tree, that is not a spanning tree, right? All right. Now apply the procedure. Already you know the steps. What is that? Arrange the given data into ascending order. Okay. Ascending order with respect to distance. Distance here you are naming as a cost. Okay, data points pair is called as the edge. Right. So now in this graph, that means dissimilar matrix, the smallest value is what? 2. That is the pair of A, B. So data point pair A comma B. Cost is 2. Next. This is over. Now come to next one. 3. That is D and E. Pair D and E. Cost is 3. Over. Then next small is 4. Pair C and D. This is over. Then next smallest value is 5. Pair is B and C and C and E. B, C and C, E. Okay. So cost is 5. This is over. C and E and B and C completed. After that 6. A and C. A and C. Cost is 6. Over. Then after that 8. That is B and E. B and E. Cost is 8. Okay. Next 9. A and E and B and D. A, E and B, D. This cost is 9. Okay. Over. After that A and D. A and D. Right. Cost is 10. So total here how many points are there excluding the 0? 0 means similar, right? Fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here total 10 pairs are required. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So the total data points are arranged in a ascending order. Now construct the minimum spanning tree. Construct the minimum spanning tree. Okay. By joining the data points with edges which is having the low cost. Okay. And so on. Now look at this. MST will be reported. A and B. I join the A point and B point. This is the edge, cost is 2. Then D and E. D and E. These two are formed with cost 3. Then C and D. Here there is a C and D. Formed with a cost of 4. Edge formed. B and C. Yes. B and C. That is formed with a 5. Then see this. 1, 2, 3, 4. 4 edges are already present. So remaining kya hai? Nodes. 5 nodes, 4 edges. That's it. And remaining compulsory loops are formed. You just see this. BC over CE. CE. If I connect C and E, it is looking like a cycle. So don't connect. Loop formed. Then AC. If I connect AC, that is also loop formation. BE. BE. This is also loop creation. Then AE. AE. If I connect AE, correct now? So this is also looking like a one loop. See this? If AE is connected, then what is this meaning? This become a total loop na? Okay. BD. If BD connected, again that is a loop. Then AD. AD connected. If AD connected, then that is also one loop. Yes. So there is no loop in the tree. That is the minimum spanning tree. Right? So these are pairs which causes loops. Causes loops. That's what we are not connecting. Alright. After this, apply the complete linkage. Why we are applying complete linkage? Complete linkage concentrates on the maximum distance between the clusters. Maximum distance means more dissimilarity. And a cluster beach में more distance is required. When more dissimilarity is present, prediction become accurate and a prediction become efficient. More dissimilarity between the cluster is always gives the good symptom. Okay. If you see the minimum similarity between the clusters, there is a possibility of the mispredictions. Minimum similarity is there between the clusters. Mispredictions possible. So maximum distance is there. That means more dissimilarity is there between the clusters. Then predictions may be accurate. So that is the reason we are applying the complete linkage. Complete linkage concentrates on the more distance. Okay. Now remove the edge which is having the more cost, more distance. Okay. Form the clusters. Right. So now here what we need to do? Apply the procedure. Remove the edge which is having more distance or cost to form the clusters. Okay, in bracket, complete linkage. If they are asking the single linkage, concentrate on the shorter distance. Shorter distance means similarity will be more between the cluster. When similarity is more, there may be a possibility of misprediction. When dissimilarity is more, there is no mispredictions possible. So predictions are accurate. So that's what I use the complete linkage here, right? In the question, if they are saying single linkage, then you should follow the minimum distance. Complete linkage, you should follow the maximum distance. For the best output, best efficiency, we are always using the complete linkage, because more distance, more dissimilarity between the clusters gives the accurate predictions. All right. So now here what we need to remove? So that is remove the edge between C and B. Okay, so this is the more cost, therefore this will be removed. Now graph will be reconstructed. So what is that? A, B, 2 and C, D, E, like this. So here two clusters are formed, right? So now what we need to do? Take the maximum distance edge and remove it. So here remove edge between C and D. C and D. Okay, this is 4. That's what this is removed. Now what we have? A, B. This edge weight is 2. Then C. Correct. Now D and E. This edge weight is 3. So now independent cluster present with the data point C. After that, remove edge between D and E. So what is this? A, B. This connection is already present. Now C is there, D is there, E is there. So now here what happens? This is the longest distance that is removed. And after that, remove edge between A and B. Remove edge between A and B. So now here what you have? A, B, right? Because this is the edge. So A, B, C, D, E. Now see, until we are getting the independent data points, we are following the same method iteratively. So in every iteration, we are taking the maximum cost edge, remove that edge. Then clusters are formed. That means in the top to bottom approach of a clustering, initially we are taking the major cluster which contain the combination of all the data points. Major cluster which contain the combination of all the data points. So when we are splitting that, we are concentrating on the dissimilarity. So more distance means more dissimilar. That is the reason by using complete linkage, we are going to split the major cluster into subclusters. In that subcluster, if you have a independent cluster, that is not possible to further splitting. When we have a dependent cluster, that means cluster with multiple data points, then there is a possibility of further splitting. Okay, continue this procedure until we are getting the independent data point clusters, or until all the edges are removed from the tree. This is the procedure. All right. So now specify the tree structure. What is the tree structure here? So initially we have a all data points combination A, B, C, D, E. This is the cluster, major cluster. First time this cluster is dividing into two parts. What are the two parts? A, B into one cluster, then C, D, E into another cluster. This is the first time. Okay. After that, this C, D, E will be connected, divided into, splitting into, this is the split into C and D, E. Next time, this D, E will be splitting into D and E. And last time, this AB will be splitting into A and B. So if you see, this is the first split. Okay, this is the second split. This is the third split. This is the fourth split. Okay, so like this we are dividing the total major cluster into subclusters until we are getting the independent data point cluster. This is the top to bottom approach. Clear? So top to bottom clustering is this. So here major cluster K1 is A, B, C, D, E. Then second, AB is one cluster and C, D, E is another cluster. Then K3. Then what is this? AB is one, C, D is another. Then K4. AB is one cluster, C is another cluster, D and E become independent clusters. Then K5. A is the cluster, B is the cluster, C, D, E. Like this, we are going to take the top to bottom decomposition. That is top to bottom clustering. Top to bottom clustering is called as a divisive clustering. Top to bottom clustering is divisive clustering. That's it. I hope you understand the question and the associated solution. Okay, copy that. So practice the questions like this. When you practice more questions, you may get the more perfection. Why clustering is required? Okay, all the points you need to understand. Why clustering is required? Clustering is required to group the data elements based on the similarity. That is a unsupervised learning. Without labeled data, if you want to learn something, we are grouping the information based on the similarity. Okay, so here similarity measure is distance. Euclidean distance is used as a measure for the similarity. Okay, when the distance between data points are very less, then data points are more similar. Distance between the data point is large, then data points are more dissimilar. Okay, so within the cluster similarity is more, between the cluster dissimilarity is more, then only predictions are accurate. That's it. Copy it. Copy it quickly. Copy it. Completed? Copy it quick. All right. So now let us take another question which is related to diffusive clustering only. You may apply the agglomerative clustering also. That is your choice, right? But question ki accordingly you need to apply the method. Question is, consider the following data set and report the clusters by using divisive clustering method. See this, observations, data point 1, data point 2. These are the observations A, B, C, D, E. Yeah, this is given. So when the statement is like this, when the question is like this, then your task will be increased and your responsibility will be increased. What is your responsibility? First, to generate the dissimilar matrix, that is distance matrix, based on the measure of Euclidean distance. Later, arrange the data points in a ascending order. After that, construct the minimum spanning tree. Then remove the edge which is having the more distance. Repeat the same procedure until all edges are removed in the tree. Clear? Right. Take the question. Then solve it. As I explained earlier, in the classroom, I am going to take the worst case of the scenarios. That means I am going to explain the concepts and questions in the worst scenario. That means lengthy questions I am going to explain by taking the raw material to ending, right? So, but in the exam, they will formulate the questions in a optimized manner. Okay, that's what all the basic steps of procedures involved in the questions I am going to explain in the class. Okay, this is the complete raw material. This is the raw information. ये raw information हमने clustering करना चाहिए तो पहले dissimilar matrix prepare करना. First we need to prepare dissimilar matrix. Okay, based on the measure of equivalence distance. Okay, right. So do that. First, step 1 is what? Prepare the dissimilar matrix. That is distance matrix by taking the measure of equivalent Euclidean distance. That is square root of x1 minus x2 whole square plus y1 minus y2 whole square and so on. So this x, y, these all are the data points. X and y, z, these all are the data points. Okay, all right. So now I want to take the distance between, देखना, distance between A and B, and also take the distance between A and C, then distance between A and D, and distance between A and E. So we need to calculate the distance between all combinations, right? AB combination, AC combination, AD combination, AE combination. Okay, how the data point A similar or dissimilar to other data points, that will be specified with a Euclidean distance, right? Now what is the formula here? That is square root of AB points A to B 5, 2 minus 5 whole square plus 4 minus 6 whole square. Report the value. Similarly, calculate it. AC, A 2 minus 8 whole square plus 4 minus 8 whole square. Report it. AD 2 minus, okay, D 10 whole square plus 4 minus 12 whole square. Report that. AE square root of 2 minus 12 whole square plus 4 minus 10 whole square. Okay students, calculate this. I just calculated the distance between A point to all other points. Correct? That distance tells how much A is similar to other components, or how much A is dissimilar to other data points. Okay, right, compute that. What is the computational value? I calculated like this. This is 3.6. This is 7.21. And this is 11.31. Then this is 11.66. Okay, verify. You please cross-examine this. Is your values are matching or not? I calculated like that. This is the distance. Now come to the distance between data point to data point B to other data points. Now see this. Here I want to take distance of BC, because of distance of AB is also equal to distance of BA. And A to B distance, if you identify, B to A distance is also same. So no need to calculate the B to A distance again. That's what distance between B and C, and distance between B and D, and distance between B and E. Okay, now square root of B is 5, 5 minus 8 whole square plus B 6, 6 minus 8 whole square. Calculate that. Next, square root of 5 minus 10 whole square plus 6 minus 12 whole square. Next, BE 5 minus 12 whole square plus 6 minus 10 whole square. So report the values. All of you, please calculate that. calculate that. Okay, so I computed this 3.6, 7.81 and 8.06. You please cross examine, all of you please cross examine the values. So this is the distance between B and other points. So now what we need to do, we need to take the distance between C and other points. Distance between C, A, no need to calculate because AC already calculated. Distance between CB, no need to calculate, already BC calculated. Now distance between CD and distance between CE, that's it. Now square root of C value 8 minus D value 10 whole square plus C value 8 minus D value 12 whole square, then 8 minus 12 whole square plus 8 minus 10 whole square. All of you calculate these two values, report it. I calculated 4.47 and 4.47. Okay, cross examine that. After this, what you have? Last one, D, distance between D and E, that's it. And remaining combinations are already ready. So D, 10 minus 12 whole square plus 12 minus 10 whole square. Okay, calculate this. So calculated value is 2.82. Bus. Okay students, yeah, this is the way to identify the distance between the data points, right? First point, distance calculated with respect to all other points in the given data set by using Euclidean distance, right? Now prepare the dissimilar matrix. Dissimilar matrix is like this. What is the dissimilar matrix? A, B, C, D, E. A, B, C, D, E. Okay. A, both are similar, distance 0. Na A, B, they given na 3 point calculated 3.6, 7.21, then 11.31, then 11.66 calculated. And next B, BB 0. Okay, A, B, B, A, dono same. This value will be replicated here itself. Okay, all right. So now here 3.6, 7.81 and 8.06. Next, come to this. CC, distance is 0, but you know CA, AC, this will be same now. This is 7.21, correct? Then BC, BC value, CB value same, 3.6. This is common, right? That is the reason here CD 4.47, 4.47. Yes, taken. Next one bolo. D, DD 0. But you know that AD, DA 11.31, this is same. And next 7.81, this is same. And CD, DC, dono same, 4.47, these are same. Okay, all right. So that's what you are taken, 2.82 and remaining 0. So these all distances, this will be the common values actually. Okay, so diagonal value is 0, lower triangle value, upper triangle value will be same. Okay, all right. So this is the dissimilar matrix. So by using this dissimilar matrix, we are going to form the ascending order of a data. Okay, right? So in the paper, hopefully we are just predicting the questions only, because this is a first time newly added paper in the GATE. Okay, so in the paper they may ask the question of generate the dissimilar matrix based on the given input data set. So this may be the one question, dissimilar matrix. Fine. Now further proceeding is this. What is the further proceedings? Prepare the, arrange the data in a ascending order. Okay. So what is the ascending order here? Smallest value क्या है इसमें? 2.82. This is what? DE. DE cost is 2.82. This is the cost. Cost means distance. This is the pair. Data points pair. All right. Next, what is the next smallest value? Smallest value next is 3.6. 3.6. So AB and BC. AB, BC. These are having the same weight. 3.6, 3.6. Next one क्या है? Smallest value 4.47, 4.47. That means CD, CE. CD, CE. 4.47, 4.47. Right. Next is what? Next 7.21. This one. 7.21. AC. 7.21. Next is what? 7.81. That is BD. 7.81. Over. Next is what? 8.06. BE. Right. Next 11.31. AD. 11.31. Next AE. 11.66. Now see how many points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all 10 points are considered. All right. So now we are preparing the MST, minimum spanning tree. DE, by taking the low cost. DE. This is D, this is E. So दोनों बीच में edge is formed with cost 2.82. Next 3.6. A, B. A is there, B is there. These 2 points edge is formed, that is 3.6 weight say. Then BC. C is here, so that 3.6 is the cost over. Then CD. This is the CD. CD. Cost is 4.47. Is it okay? Then CE. If you say CE, this is a loop. Then AC. AC, that is also a loop. You know one thing. Total nodes are 1, 2, 3, 4, 5. 5 nodes means 4 edges. So all 4 edges are present. So n nodes are there, n minus 1 edges. So every node is having at least one visit of the data point. Okay. So every node is connected, correct, at least with one edge already there. BD. BD किया तो भी loop आएगा. AE. Sorry, BE. BE is also creating the loop. AD. AD also creating the loop. AE. AE also creating the loop. So these are the possibilities of loop formation. So minimum spanning tree means there is no self loop in the tree. Okay. Now immediately apply the complete linkage. That means remove 4.47 BD, sorry, remove DC edge. Remove DC edge so that D is there, E is there with 2.82, then A, B, C, like this we have. This is 3.6, this is also 3.6. All right. So after that, remove. Here, dekho, this is a 3.6, this is also 3.6. Then when we have a common, then you need to take any one. So let me take AB edge. AB edge. So here D, E, that edge is already present, 2.82. Now this is A, here B and C. This is 3.6. Next, remove BC edge. Then D is there, E is there already with 2.82. Okay, now A, B, C, like that. All right. So now next is what? Remove DE edge. So now D, E, A, B, C present. So all edges are removed. Therefore, the total cluster formation is completed. Now take the top to bottom approach. So what is the top to bottom? Now see, first all the data points combination is a major set. A, B, C, D, E. This is the major cluster. This will be dividing into two parts first. Okay, first split is what? First split is 2 points. First split is 2 points. Okay, all of you please draw that because you know the procedure. You know, please conclude that. Okay, created the formation or not? First what we did, DE is one side and next ABC is another side. This is the first split. After that, here BC, ABC, here even if you take A first you can take, or you take C first you can take. Okay, right. So A I taken, therefore BC coming in another, right? After that, this BC, B is coming, next C is coming. All right. Then after that, DE, this is splitting, top to bottom. Is it okay? All right. So you know this is the first split. This is the second split. This is the third split. Right? This is the fourth split. That's it. So here two options are there. In the second split, you may get A, B and C, or you may get A and BC. There are two combinations possible. Two combinations. Because of that weight will be same. Right? So now see the cluster 1. What is K1? K1 is major cluster A, B, C, D, E. Then next one, next split is DE is one cluster, ABC is another cluster. Then TK3, DE is one cluster, Okay, and A is one cluster, BC is one cluster. Okay, here you may change the order also. DE is one, AB is one, C is another one. Here one more option may be present. Okay, then K4, DE is one, A is one, B is one, now C is one. Now K5, here D is separate, E is separate, A, B, C. So top to bottom. Bas. So here alternatively what is present? Here DE is one, either AB present and C present. Okay. So finally here it is common. This is one more alternative. In K3, this is also alternative. Okay students, I hope you understand this method clearly from the scratch. I given the data points, I formulated the dissimilar matrix, I constructed the MST, minimum spanning tree, later formed the clusters, top to bottom, that is the divisive clustering. Okay, copy it. I am showing you the screen once again for your copying. Yes. Okay. Now this is next portion. Okay. Yes, this is the last one. Now I hope you understand this procedure clearly. Now take the next one. Okay, now take question. Consider the following distance matrix comma form the clusters from top to bottom method, top to bottom approach. All of you please do it faster, quickly. P1, P2, P3, P4, P5, P1, P2, P3, P4, P5. 0, 9, 3, 6, 11, 0, 7, 5, 10. Next 0, 9, 2. Next 0, 8, 0. Okay. See students, please copy the question. Students, in this subject, Actually, what we need to understand is we have a different algorithms, different approaches, different methods to train the model or to train the system or to learn the system. Okay, to train the system we have a different algorithms. So at the time of reading this subject, you should know what is the aim of the algorithm. That's it. By knowing the aim of algorithm, we are going to apply the different input data sets. So when we are applying the different input data sets on the algorithm, it will give the perfection of that topic. That's it. So within 1-2 lines, we need to complete the clustering. Clustering concept के लिए within 10 minutes we need to complete. Top to bottom, bottom to top. If you take anyone's help, that person will complete the explanation of top to bottom, bottom to top within 5 to 10 minutes. Because that is a procedure. That is a algorithm, step by step statement explanation. But when we are going to get the perfection in that algorithm, you need to submit different input sets into the algorithm and observe the output of the algorithm. Then only perfection is there in your hand. That is the reason I am going to explain some set of the questions based on every algorithm, right? So previously I explained the agglomerative clustering. Now we are watching the divisive clustering, right? Bottom to top and top to bottom clustering, right? Now apply the procedure, top to bottom approach, solve it. Okay, you know the method. First, what we need to do? Ascending order. Okay, pair and cost. Cost is nothing but distance. So ascending order, low to high. So P3, P5. Cost is 2. Then this is over 3. P1, P3. Cost is 3. Over. Then 5. P2, P4. 5. Next 6. P1, P4. Over. Next 7. P2, P3. Okay. Next 8. P4, P5. Right. Next 9. P1, P2, P3, P4. P1, P2, P3, P4. Weight is 9. Okay. Next 10. P2, P5. Then P1, P5. That is 11. Alright. So now I take in the total ascending order of the data points based on the distance. Every time you know the meaning of distance. When the distance is low, similarity is more. Distance is more, dissimilarity is more. Okay. So here we arrange the data in terms of the ascending order. After that, construct the spanning tree. So P3, P5, these two data points are connected. Cost 2. P1, P3, here P1, connected, cost 3. Then P2, P4, P2, P4, connected, cost 5. Next P1, P4, P1, P4, connected, cost 6. Okay. Then P2, P3, P2, P3, P2, P3, there is a loop form. P2, P3. Then P4, P5 loop, and P1, P2 loop, P3, P4 loop, P3, P4, P2, P5 loop, and so on. This is also P1, P5 loop form. Okay, possibility of loops. So don't connect them. Alright, now after that, organize the data, arrange it, split it. What we need to do first, remove this one, P1, P4 edge. So what is this? P1, P4 edge, if you remove, P1, P3, P5 is there with weight 3, 2, then P4 and P2 separated with weight 5. Next, remove P4, P2 edge. Okay, so now P1, P3, P5 is there with cost 3 and 2. Now P4, P2 become independent. Okay, now remove P1, P3 edge. So now P1, P3 removed, therefore here one more edge is there, then P4 and P2. Alright, next remove P3, P5 edge. So P1, P3, P5, P2, P4, like this we have. All the edges are removed, then stop the process. Now report the tree. Major tree is P1, P2, P3, P4, P5. All combination of data points is the major cluster. Now that is initially splitting into two parts. Okay, so one is P1, P3, P5. This is one cluster, and P4, P2 is another cluster. Next is what? P4, P2. This is decomposed. P4 and P2. Okay. Next is what? P1, P3, P5. That is decomposed. Splitting. P3, P5. Now P3, P5. P3 separate. P5 separate. Is it okay? Right. Here splitter. This is the first split. Right. This is the second split. This is the third split. Okay, this is the fourth split. Like this, we are arranging the data. Okay, all right. So now cluster. Bolo K1, P1, P2, P3, P4, P5. Major cluster, and first splitting P1, P3, P5 and P4, P2. Then next one P1, P3, P5. Okay, then P4, P2. Right. Next one P1, P3, P5, P4, P2. Then next one P1, P3, P5, P4, P2. We get the individual data points cluster. So stop the process. So this is the top to bottom clustering. Hope you understand, right? Copy it. Completed? Okay, students. All right. Now take one more. Completed copying? Okay. Now take next one. Consider the following minimal spanning tree. And form the clusters. Minimum spanning tree, form the clusters using top down. Top to bottom approach. So this is a again small question, right? Because they already given the spanning tree. No need to draw the spanning tree. Yes, this is the spanning tree given and ask you to form the clusters top to bottom. Then how to solve it? You know that. Apply the procedure, do it fast. I am waiting for your response. So what we need to do? Remove the edge. Remove the edge which is having the more cost. Continue like that. So here, what is the method? First, from the MST, minimal spanning tree, verify the more cost, that is 7. This will be removed. So first remove TF edge. So what is this? A is there, B is there, C is there, E is there, G is there, F is there, H is there. Now D become separate. Fine. So these weights are common. What is given here? 4, 2, 5, 6, 1, 3. Next, remove remove EG edge. Okay, so now A, B, C, E. Now G is separate. F, D, H. Now the connections are like this. Connections are like this. Why? We removed this, right? This will be deleted. Then what is the weight here? 4, 2, 5, 1, 3. Now take next highest. Remove BE edge. Very simple thing, right? So because of this is having more. So what is this? A, B, C. Okay, they are like this. 4 and 2. Then E, F, H. They are like this. 1 and 3. Okay, G is there. Already D is there. Fine. Now, what is the next one? Remove AB edge. Okay, so A, B, C. So here 2, E, F, H. Here like this. 1, 3. Then D, G. Okay, so here more weight is 4. That's what removed. More distance means more dissimilarity. Okay. Remove FH edge. Okay, that is A, B, C. This is 2. Then E, F. This is 1. Then H is separated. D is separated. G is separated. Okay. So this is 3. More weightage removed. Then next, remove BC edge. Okay. This is higher weight. Remove. So what you have? A, B, C. Then E, F. This is 1. Then H, G, D. Okay, last is what? Remove this edge. Fine. Now remove EF edge. Now you have A, B, C, E, F, H, G, D. All are independent, right? This is the way of splitting clusters from top to bottom. So here diagram is A, B, C, D, E, F, G, H. This is the major cluster. So now initially this is splitting like this. Splitting into, this is D. And after that A, B, C, E, F, G, H. This is the first splitting. Now next splitting is what? This will be dividing into 2 parts. G, and after that G is separated now. G separated. Now A, B, C, E, F, H. This is next. Then after that what is there? This will be dividing into 2 types. A, B, C. and E, F, H, like this, divided. Okay. So next one is what? This is A is splitting, then BC present. Okay. And next here dividing, H is separated, then E, F present. Okay. Next here BC, based on what? Based on the weight or cost or distance, you know that. And next one E and F, dividing like this. Okay. All right. So now you just see the splitting levels. Okay. This is first split. This is second split. Okay. So this is third split. This is fourth split. Is it correct? That is fourth split now. Then A separated. Then this is fifth split. Okay. Then BC. This is the sixth split. This is the seventh split. Okay. Total data elements 1, 2, 3, 4, 5, 6, 7, 8. 8 data elements. Now total 7 splits are there. So what are the clusters present? Clusters presence is like this. K1. A, B, C, D, E, F, G, H. This is 1. K2. D, A, B, C, E, F, G, H. Then K3. D. Okay. G, A, B, C, E, F, H. Then K4. D, G, now A, B, C, E, F, H. Next K5. D, G, A, B, C, E, F, H. Okay, then K6. D, G, A, B, C, right? H, E, F. This is. Then K7. D, G, A, B, C, H, E, F. Now again splitting, because of dependent split node is there, not independent node, that you can say split node. So D, G, A, B, C, H, E, F. That's it. So all the clusters are having the independent data points in the bottom level. In the top level, we have a single cluster. It is a combination of all data points. So top to bottom clustering is the divisive clustering. I hope you understand this analysis, right? Thank you. So copy this. I am just showing you the screens, solution screens. Okay, students, copying done. Copied. Okay, so up to this we covered the clustering mechanism, that is bottom to top agglomerative clustering, top to bottom divisive clustering. Okay, clustering concept completed.